All right, today in Algebra 1, we're going to be talking about factoring polynomials by taking out the greatest common factor, or what we have known as the GCF. Okay, but before we do that, what I would like for you to do is take some time and try to find the greatest common factor between 28 and 21, 64 and 20. And I want you to think about x to the 7th and x to the 4th. What is those two's greatest common factor as a pair? And so take some time. Try to solve this on your own or with a partner near you and see if you can determine what the greatest common factor between these three problems are. Okay, so pause the video and try answering this with a partner next to you, or if you are virtual, try to do this on your own, and then we will talk about it once everyone's done. So please hit pause. All right, if we take a look at this, question 1 says, well, let's find the greatest common factor between 28 and 21. Well, if I look at this, I can find the greatest common factor by breaking each of these numbers into its prime factors, or its smallest parts. And so when I do that, I would break down 28 to be equal to 7 times 4. But we also know 28, I can break down 4 even more to be 2 times 2. And what we notice here is 28 is broken down into its smallest parts, 7, 2, and 2. I can't break these numbers down anymore besides 1 in itself. Okay, this is what we called in the past the prime factorization. All of these are prime numbers. And similarly here, if I break down 21, 21 is 7 times 3. Well, at this point, 7 and 3 are prime factors. And so if I look between the numbers 28 and 21, well, the greatest common factor is the numbers that both of these share. Well, if I look at 7 times 2 times 2 and 7 times 3, what we can notice is between 28 and 21, the only number that they have in common is 7. So the greatest common factor here, the greatest common factor between 28 GCF between 28 and 21 is 7. Okay. At this point now, I can say that do the same thing between 64 and 20. 64 is really 8 times 8. Okay. But I can break down 8 times 8 to be 2 times 2 times 2. That is 8, and this will take care of the first 8 here. This 2 times 2 times 2 will take care of this 8. Well, I need to multiply that by 8 again, so really I'm just going to multiply that by 2 times 2 times 2 again. And this 2 times 2 times 2 will take care of that second 8. Okay, and all of this is its prime factorization for 64. And let's do the same thing with 20. 20 is 5 times 4. Well, again, I can break down 4 to be 5 times 2 times 2, where 4 is 2 times 2. And now again, what we can do is we can look at these two prime factorization and see, well, what numbers do we have in common? Well, I can see I have one pair of 2's in common, and I can see and I have another pair of 2's. And so the greatest common factor, the GCF between 64 and 20 is 4. Okay, because 2 times 2 is 4. Everything else left behind has nothing to do with the greatest common factor here. It's just the numbers that both of them share. Okay, there's no 5 in the rest over here, and there's no other 2's left with our factors of 20. Okay, and if we look at this, if I asked you again with question number 7, well, I'm gonna have to write this one out because this does not allow me to do exponents, but x to the 7th and x to the 4th. Well, x to the 7th, another way of saying x to the 7th is really just x times x times x times x times x times x times x. This is x to the 7th. I have 7 x's here. 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 x's here. This is another way of saying x to the 7th. And x to the 4th is x times x times x times x. And if we look at this, what we can realize here is just like what we did in questions 1 and 2, we can take a look and highlight the common factors here, and we can see that we have x's in common. And more so, what we can say is the greatest common factor here in question number 3 is x to the 4th, x to the 4th power. It's x times x times x times x, or x to the 4th power. Okay. And again, the reason why I wanted us to go over these 3 questions is because we're going to be doing something called factoring. And to start off, we're going to be talking our first method by factoring by the greatest common factor. Okay. So if anyone still needs time to write this one down, please feel free to pause the video. But then I'm going to move on. All right, moving on to the next point here. At this point, then, like I said, what we're going to move on to is factoring. In fact, this factoring is what we're going to be taking the rest of the time of the rest of the year doing. And so we should probably talk about what factoring is. And so factoring polynomials is this process of breaking a polynomial to its smallest parts, or what we call factors. Okay. And in the past, what we were doing is we were multiplying 2 polynomials together, and we got a final resulting polynomial. In this case that you see here, I have a binomial being multiplied by a binomial, in which it resulted in a trinomial. Okay. But these polynomials prior to us being multiplied were what we called that polynomial's factors. Now, today we're not going to do anything complex to get these types of factors. That's something that we're going to be doing over the next couple of weeks. But for today, what we're just going to be doing is we're going to be taking out the greatest common factor from each of the terms in a polynomial. Okay. We'll see what's in common in all terms. And so if I look at this, if I take a look at this trinomial here, 12x squared minus 36x plus 8, well, I can break down each of these terms. And so let's do that. Let's see what each of these have in common. So 12x squared is 2 times 2 times 3, because 2 times 2 is 4, 4 times 3 is 12. Okay. But we can't forget about the x squared, so it's going to be times x times x. And negative 36 is negative 1 times 2 times 2 times 3 times 3, because it's negative 1 times 2, which is 2. 2 times 2 is 4. 4 times 3 is 12, and 3 times 12 is 36. So it's be negative 36 times by x. Okay, if you wanted to, you could break 36 down to be 4 times 9, but then 4 is being broken down to 2 times 2, and 9 is being broken down to 3 times 3. Okay, and as we said in the previous example, we can break 8 down to be 2 times 2 times 2. And now taking a look at this, what do they all have in common? Well, what they all have in common is 1, 2, but also a second 2. So the greatest common factor between 12x squared, negative 36x, and 8 is going to be 4. Okay, it's going to be 4. And so if we continue here, and again, you guys have these notes in today's folder in Schoology, so if you haven't opened them up already, again, that'd be something you should be doing as well. But moving on here, we said the greatest common factor between these 3 terms is 4. And again, I highlighted them here as well, so you have these highlighted in your notes. And what you can notice here is I did make a typo on this slide, and we'll get to it at that point, but the greatest common factor here is 4. So what we're going to do is we are going to factor out, or pretty much undistribute this 4. We're going to take it out of each term. So what we're going to do is we're going to take out this 4, take it out, and here I said 4x, that's my typo here. It's 4x here, not 4. I'm going to take this 4 out of each term. Let's just take it out. We're going to multiply this 4 and break it down between 4 and its smallest parts. So taking out this 4, what's left of the first term then? If I take out this 4, what's left is this 3 times x, or 3x squared. So 12x squared is 4 times 3x squared. Negative 36 is 4 times negative 9x. And 8 is 4 times 2. And well, if they all have it in common, let's take it out and take 4 and multiply it by 3x squared minus 9x plus 2. 3x squared minus 9x plus 2. And what we can notice here is we can do this because if we were to distribute this 4 back in, well, 4 times 3x squared gets us back to that 12x squared. We just said 4 times 3x squared is 12x squared. And then we can distribute this 4 to the negative 9x. And 4 times negative 9x is negative 36x. And 4 times 2 brings us back to that 8. And so we're taking 4 out of each of the terms, and now we brought it back to its simplest form. And we have factored. Okay, so we really just took out 4 out of each term. Okay. So that's going to be our strategy. Our strategy for today is to find the greatest common factor between our terms in our each polynomial, and then factor it out, kind of undistribute it, take it out of each term, and multiply by whatever's left in each term. Okay. So moving on to the next example. What I want you to do with questions 4, 5, and 6 is see if you can find the greatest common factor and factor it out. Pause the video so you can take some time to answer this question, and we will talk about this in just a moment, but take some time either talking about it with a friend or trying this by yourself. All right. While thinking about this, let's see if we can figure out what we're going to be pretty much undistributing out. Let's see what we're going to take out of each term. So 7x squared is the same thing as saying this is 7 times x times x. Okay. And 35 is like saying 7 times 5. And so between these two terms, what do they have in common? Well, the only thing they have in common is this 7. So we're going to take out this 7 from 7x squared and take it out in 35. That's what's common in both. I can redistribute that 7 back in and get the same thing. And so when I take out this 7, what is left of the first term? Well, what's left is x squared. What's left of the second term? Well, second term is left is plus 5. Okay. And now I'm done. I factored out the 7, and now I'm done by factoring out the greatest common factor. Okay. Question number 5. 15x squared minus 40x plus 100. Well, 15x squared is equal to 3 times 5 times x times x. Okay. 40 is equal to, actually it's negative 40, sorry. Negative 40 is equal to negative 1 times 2 times, well, yeah, times 8, but that's 2 times 2 times 2 times 5 times x, okay? So again, 2 times 2 times 2 is 8. 8 times 5 is 40, times by x is 40x. And then we have 100, which is 2 times 2 times 5 times 5. Because 2 times 2 is 4, 5 times 5 is 25, 4 times 25 is 100. Okay. And what we can notice is the greatest common factor between 15x squared, 40x, and 100, in this case, is 5. And so after we factor out a 5, I can say, well, 15x squared is 5 times 3x squared minus negative 40x is 5 times 8x plus 100 is 5 times, oops, not 5 here. I went a little bit ahead of myself. It's 5 times 20. And again, we get these numbers 20, 8x, and 3x squared by looking at what's left over. Well, what's left over here? Well, let me highlight this. What's left over is 3x squared. 3x squared. What's left over here? Negative 8x. Negative 8x. And then 20. Okay. And at this point, I have factored out by the greatest common factor. Okay. Question number 6 states 18x to the 4th is equal to 9 times 2, but 9 is 3 times 3. So 3 times 3 times 2 times x times x times x times x. X times x times x times x is x to the 4th. And very similarly, negative 12x cubed is negative 1 times 3 times 2 times 2 times x times x times x. Okay, because 3 times 2 times 2 is 12. Okay, and then x times x times x is x cubed. And last but not least, 24x squared is equal to 2 times 2 times 2. That's 8. 8 times 3 is that 24. And then x times x. And so taking a look at this, what is our greatest common factor? Well, our greatest common factor in this case is, well, we notice there's a 3 in each. There's a 2 in each. So 3 times 2 is 6, but there's also an x squared in each. So our greatest common factor here is 6x squared. So we're going to take out a 6x squared from each term. What is left in the first term? Well, what's left is 3x squared. What's left of the second term? We have negative 1 times 2 times x, which is negative 2x. And what's left of the last term? We have 2 times 2. That is 4. And this is our final answer. Okay, this is how we factor by this greatest common factor. Okay. Pause the video. Again, if anybody needs any more time to write down these notes, but then we're going to move on. All right. So taking a look at this, I'm going to erase all what's on here. Now, this brings us to our next big idea. When do we factor out a negative? Okay. Well, whenever we factor out a negative, this occurs, and you can see it's highlighted, if the polynomial is in standard form and the coefficient out in front, or the number out in front, this is also known as the leading coefficient. If this number out in front is negative, then we are going to factor out a negative. So if we consider this following example, negative 14x squared plus 7x minus 28, well, what we realize here is negative 14 is negative. So what we're going to do is we know we're going to factor out a negative 1 at some point. Okay. Well, if you take a look at this, negative 14x squared is negative 1 times 7 times 2 times x, because negative 1 times 7 is negative 7. Negative 7 times 2 is negative 14 times x. 7x, well, if we're taking out a negative, I have to write out a negative 1 times by negative 7 times by x, because negative 7 times by negative 1 is positive 7. And then negative 28 is negative 1 times 2 times 2 times 7. And what we realize here is the greatest common factor is negative 7. Here we have negative 1 times 7 to get negative 7. Here we have negative 7 just right here. And we also have another negative 1 times 7 to get negative 7. So the greatest common factor is negative 7. And if we factor it out, we get negative 7 times by what's left in each term again, times by 2x squared, negative 1 times x, which is just negative x, and 2 times 2, which is 4. Okay. So whenever that leading coefficient is negative, when it's in standard form, note it has to be in standard form, then we're going to factor out a negative. So taking a look at this next example here. Taking a look at this next example, and I'm going to actually, I need to clear my drawing. Okay. Try questions 7 and 8. 7 and 8. Okay. Yeah, if you haven't paused, make sure you pause. Work with a partner if you need to, and then we're going to finish up this 7 and 8. So taking a look at this, negative 42x to the third power is going to be equal to negative 1, because this is a leading coefficient. This is in standard form, and the leading coefficient is negative. I should have started off by saying that, but because this leading coefficient is negative, we are going to add in that negative 1. So negative 42 is negative 1 times by 2 times 3, that's 6. 6 times 7 to get 42. And then x cubed is x times x times x. Okay. Here, 36x squared. Well, again, because we are factoring out a negative, I need to have this negative 1. So I'm really actually going to do this. I'm going to write negative 1 times negative 1. That's going to give me a positive number, and then the rest of the numbers are going to be positive. Negative 1 times negative 1 gives me a positive number, and then 36 is 6 times 6, which is 2 times 3 times 2 times 3 times x times x. And again, we have this double negative 1 times negative 1, so that we get a result that is, gives me a positive 36 because of this positive 36. Okay. And the only reason why we're doing negative 1 times negative 1 is because the leading coefficient's negative, so we're going to factor out a negative 1. Okay. And very similarly here, 72x is positive, but I know I'm going to be factoring out a negative 1. So I'm going to do negative 1, but to make this positive, I need to multiply this by negative 1 again. And 72 is 8 times 9. Well, 8 is 2 times 2 times 2. 9 is 3 times 3, and then times x at the end, x here. Okay. So what is my greatest common factor? Well, again, from the very beginning, we knew we were going to take out a negative 1. So a negative 1 is a part of our greatest common factor. 2 is a part of our greatest common factor. 3 is also part of our greatest common factor. And x is a part of our greatest common factor. So what would be the greatest common factor here? Well, 2 times 3 is 6. -1 is -6. So it's going to be -6x is going to be my greatest common factor. -6x is going to be my greatest common factor. Well, what's left of the first term? What's left is 7x squared. What's left of the second term? That is -6x. And what's left of the third term? -12. 2 times 2 is 4, times 3 is 12, times by -1, which is -12. And now this is factored out by the greatest common factor. Okay. Looking at question number 8, I have -9x plus 27x squared. And I hope at this point, when you saw question 8, some eyebrows were raised, because remember, when we factor out a negative, that only occurs when the equation's in standard form. But this is not in standard form. This is not in standard form. So let's put it in standard form. Putting this in standard form, we get 27x squared minus 9x. Now this has decreasing exponents. This had increasing exponents, but to be in standard form, I have to decrease exponents, just like how this is in standard form, decreasing exponents. And now when we look at this, this does not have a leading coefficient that's negative. 27 is not negative, so we would not be factoring out a negative number here. And so 27x squared is going to be, well, 27 is 3 times 9, but 9 is 3 times 3, and then x times x. And then -9x is going to be -1 times 3 times 3 times x. Okay. And now what is the greatest common factor? The greatest common factor is 3, 3, 3, 3, x, and x. And so that would be 3 times 3 is 9. 9 times x is 9x. So the greatest common factor here is 9x. What's left over? 3 times x, which is 3x. And then -1. And there we go. And again, if you redistribute this, 9x times 3x is 27x squared. 9x times -1 is -9x. Okay. And again, pause this video if you need more time with these two questions. All right. Now, one last final big idea we have with factoring polynomials, and this works for all factoring polynomials, not just with the greatest common factor, not just with factoring with the greatest common factor. This works with all factoring, so this will be true until the rest of the year. But when we factor, we have a prime polynomial if a polynomial is not able to be factored. This is what we call this polynomial is prime or is irreducible. So let's look at 9 through 11. Determine if the following are prime or not. Okay. Determine if the following are prime or not. So I'm going to do number 9, and then I want you to do 10 and 11 by yourself. So if I look at 9, I'm going to take x squared, break it down to its smallest parts. X squared is just x times x. 4 is 2 times 2. Well, if I look at this, x squared and 4 have nothing in common. There's 2 x's here. There's no x's in 4's. In 4, there's 2 2's, but in x squared, there's no 2's. There's nothing in common. So in number 9, this is what we call prime. And so if you run into one of these types of problems, you'll just write prime and you'll be done. So try questions 10 and 11. Determine which one of these are prime, if any, and if it's not prime, factor it out by the greatest common factor. Pause the video if you need more time, or pause the video to work on this with a partner, and then we'll go over it when everyone's done. All right, looking at number 10. Is this prime? And the correct answer when you were doing this, you should have gotten this to be no, this is not prime, because 7x to the 5th is just that. It's 7 times x times x times x times x times x times x. There we go. Negative 63x squared is 7, is equal to 7 times 9, but 9 is 3 times 3, and then x squared is x times x. And 49 is 7 times 7. And so what we can initially see here is the greatest common factor is going to be 7. 7 is in all three. Only one 7 though. And so what we realize is, well, if I factor this is going to be 7 times x to the 5th minus, I forgot a -1 here, times -1, minus 9x squared plus 7. And this is now completely factored for this question. So 10 is not prime. 10 is able to be factored. But if we look at 11, 11 is 3x squared, which can be broken down to be 3 times x times x. 4x can be broken down to be 2 times 2 times x. And 9, I'm going to be going way to the bottom, 9 is 3 times 3. And if I look at all of these, and I'm sorry if you really can't see this bottom because it is bright blue, but if I look at all of these, there is nothing in common. The first and the last one both have a 3, but 4x does not have a 3. 3x squared and 4x both have x's, but 9 doesn't have an x. And so because there is nothing in common in all three, this is considered prime. Number 11 is considered prime. Okay. So this is everything that we're going to be talking about with factoring with the greatest common factor. If you have any questions, please do not hesitate to email me. But please spend the rest of the time doing the quizzes and then taking some time to do the homework. Let me know if you have any questions. Have a good weekend, and I'll see you again next week. Thanks.